This is the Greenland ice cap, a huge mass of ice and snow that runs the length and most of the breadth of the world's largest island. And these are the men of the United States Army Corps of Engineers who are fighting a winning battle against the Arctic enemy. Their mission is to finish 2 radar warning systems against surprise aerial attack from across the pole. One warning system is the dew line. It is an electronic tripwire stretching from the Aleutians across Alaska, Canada, and Greenland to Iceland. Operated under the joint control of the United States and Canada, it will set off an alarm if an enemy bomber tries to sneak through. When these 4 stations in Greenland are installed, the last gap in the radar screen will be sealed. Planes at Sandestrom, Thule, and other Air Force bases will have several hours warning in case of enemy bomber attack. This is one station in the Air Force warning system. The second radar warning system lies 600 miles to the north in the Thule defense area. This is the ballistic missile early warning system, known as BMEWS. These monster antennas will scan the communist land mass from Poland to the Pacific Ocean and will detect approaching missiles 3,000 miles away. The target date for finishing the dew line and BMEWS is the summer of 1960. Only during the summer months are cargo ships able to push their way through the ice packs that encircle Greenland. Ice, frost, and snow rule Greenland with dictatorial force. The construction problems that face the Army engineers were almost beyond belief. The ice cap is a mammoth slab, 1,600 miles long and 10,000 feet deep. Every year adds a 3-foot layer of snow. The ice cap yields to the surface earth along the coasts of Greenland, but the frost hardens the ground like concrete to a depth of 2,000 feet the year around, aptly earning the name of permafrost. The story of how the Army's Corps of Engineers conquered these mighty forces of nature is a great epic of engineering skill, imagination, and unremitting hard work. The project was carried out jointly by the United States and Denmark, for Greenland is Danish soil. Danish construction companies, using Danish workmen, were awarded contracts to build a dew line station on the west coast of Greenland and an identical one on the east coast, while Americans built the 2 interior ones on the ice cap. The coastal stations were supplied mainly by sea. Service ships kept up a summer-long flow of supplies. To save time, cargo was unloaded directly into heavy-duty trucks brought to the ship's side by naval landing craft. As soon as these hit the beach, the trucks rolled on their way to the unloading point. At the same time, Army amphibious craft delivered full loads ashore, where mechanical stevedores transferred the cargo to waiting trucks. The first thing to be built was a temporary base camp for the work crews. Next came a road on which to haul steel and lumber from the landing beach to the site of the warning station. This distance was only 4 miles as the crow flies, but detours required by the permafrost brought the final road length to 18 miles. Once the road was completed, workmen set about the construction of pipelines for fuel and water to service the crews building the radar station. Because of the difficulty of digging into the permafrost, the fuel lines, which followed the contours of the road, were installed above ground. The radar station was erected on a commanding headland of rock, 5,000 feet high. The scanning and detection antenna will be housed in a plastic radome atop the tower rising from the main building. Lifted high above the surrounding terrain, the antenna will have an unobstructed field for scanning. The two-story steel frame building is a composite structure. It will enclose the technical equipment and power generators, plus living quarters for the operational staff of about 23 men. Communication with other DEW-line stations will be held via 30-foot sending and receiving dish antennas, which will bounce signals off the troposphere. This method is practically immune to jamming by the enemy or to interference from natural electrical disturbances. Physical communication between the West Coast Station and Sandestrom Air Base will be maintained the year round by way of helicopter. This will mean regular mail, special medical care if needed, and a steady supply of creature comforts, including hi-fi records. Across Greenland, on the east coast, an identical station is going up. The weather on this side is much worse because of the stormy reaction of the warm Gulf Stream on the frigid seas. Luckily, only a 6-mile road had to be built to reach the site of the composite building. This is on solid rock over 1,000 feet high. For aerial communication with the Sandestrom base, a 4,000-foot airstrip was hacked out of the rock and tundra. Building the two warning stations on the ice cap presented different and sometimes more difficult problems. These were constructed by American crews, and every item of equipment had to be flown in over the ice cap's impassable terrain. All materials had to be designed and fabricated to fit within the hold of the C-130 cargo planes. Even these huge girders for the radar station. 8 supporting columns hold the secret of how the 68-ton bulk of the station is sustained above the ice cap. Each column consists of 2 members laced together. It is braced by a steel framework which rests on a broad timber mattress 31.5 feet below the surface. All 8 columns are connected below ground by trusses encased in timber boxes. The area is then backfilled with compacted snow right up to the original snow line. The composite building will literally be suspended from the columns, which will rise 75 feet above the snow. This will permit the building to be jacked upward as much as 30 feet over a 10 or 12-year period. Jacking will be done by 2 power-operated 350-ton hydraulic jacks at each column, 16 in all. These may be operated separately or together from a central control panel. Since the snow accumulates about 3 feet per year, jacking up the building the same distance will maintain a clearance of 19 feet above the surface. This clearance will allow the snow-laden winds to pass through under the building rather than pile up snow against its sides. Fuel for power and heat will come from 4 huge 100,000-gallon tanks sunk beneath the surface. The construction work goes on day and night in 12-hour shifts, undeterred by difficulties and discomforts. Even in the so-called summer months, these films were shot in August, the temperature rarely goes above freezing. Workmen outdoors must wear heavy gloves and parkas. But these are hardy men. Many are veterans of construction work in the Arctic. They take pride in their jobs and are keenly aware of the importance of their work. Everything possible is done to keep morale and working efficiency high. Food, good food, and lots of it, is all important. Cooks are selected almost as carefully as engineers. Meals are available around the clock. As the 12-hour shifts change, one shift may be eating breakfast while the other is enjoying supper. The men relax in warm and comfortable living quarters. A qualified physician is always on hand. No effort is spared to keep the men in good health. To the east, on the ice cap, construction goes forward on an identical station. About the only difference is that working conditions here are even more severe. This area is located many miles from the storm-plagued east coast. The men find the cold more clammy and snowfalls heavier, but these handicaps only spur them on to keep pace with construction elsewhere. All 4 new dew-line stations must be completed at the same time, end of summer 1960. Farther north at Thule, the Army Corps of Engineers labors to meet the same deadline for the ballistic missile early warning system. This station is similar to the one located at Clear, Alaska, and a third to be built in the British Isles. Interlocking, they will form a continuous radar screen against any missile attack from the far north. Each antenna is 400 feet long and 165 feet high, larger than a football field laid on its side. It is designed to withstand 12 inches of ice on its screen, plus winds up to 185 miles per hour. "20 struts brace each antenna, each embedded in huge concrete footings, founded on a gravel pad. Each strut is 40 inches in diameter. Every item here is king size. All antennas and buildings are connected by a 6,000-foot passageway, which can accommodate motor vehicles. Prefabricated, insulated panels guard against the cold. To protect against the hazard of radiation from the high-frequency antennas, copper screens insulate the floor and are welded to the metal wall panels. Power for the antennas will come from a floating U.S. Navy power plant with 3 big generators. The ship is permanently moored in a slip designed to protect it from the crushing ice. To guard the BMU's installation and the entire Thule defense area against aerial assault, the Army Corps of Engineers carried through Project Rising Star. This is an underground installation emplacing 4 batteries of the supersonic, deadly accurate Nike Hercules missiles. To make room for the elevator pits, the stubborn permafrost had to be drilled and blasted to a depth of 30 feet. Fantastic weapons, fantastic equipment, fantastic skill and stamina, all involving a combined effort by the U.S. Army and her sister services to keep America invulnerable from surprise attack from the north.